Then we shall discuss about the buoyancy force. About buoyancy, we all are aware of that whenever a body is inside the liquid or gas, then it will be experiencing some upward force, right. So, to understand it further, let us observe this picture in which we have a liquid which is filled up to this height, and this one is known as a free surface. Free surface is a surface on which we have a atmospheric pressure, right, and we know that liquids form a free surface. So, in this direction we have a x coordinate, in this direction we have a z coordinates, and this is our any arbitrary two-dimensional, or it is the projection of three-dimensional body which is fully submerged in this liquid. To know that how much force is being applied on this submerged body, we have to find out the force acting on its surface. So, for that what we do, we convert this body into several prisms. So, let us take this prism which is shown here with the help of cross hatched line, this one, and look at the top point and bottom point. At top point, this top point height from the free surface is z1, and the bottom point height is from the top surface, this is the bottom point. So, this is having z2 distance. So, upper point and lower point of this prism are situated at z1 and z2 height from liquid free surface. So, because of the z1 and z2, what will be the force by the fluid on the body will be applied, that can be calculated with the help of principle of pressure equation. So, in pressure equation we have studied that dF1 is the force acting on this prism at the top point is equal to P atmospheric, this is P atmospheric, plus P1, whatever is the pressure at this point, P1 multiplied by cross sectional area dA. What is P1? P1 is equal to rho g z1 or gamma z1. So, what is dF1? dF1 is equal to P atmospheric plus rho g z1 into dAz, right. So, dAz is the projected area in z direction. So, dF2, similarly we can find out dF2 at this point, the force acting at this point. What is the direction of the force? At this point and at this point, the direction of the pressure force is always compressive in nature. So, that is why at this point we have a downward force, and at this point also we have a upward force. That is why these pressure force will compress this element. So, dF2 is equal to P atmospheric plus whatever is the pressure here. Here pressure is designated as P2 into dAz, and P2 may be substituted in terms of the height of the fluid, which is P atmospheric plus rho g z2 into dAz. So, what is the resultant force on this prism of size dAz? dFv is equal to dF2 minus dF1. This is the force acting in upward direction, dF2 minus dF1. So, by using the previous two formulas of dF1 and dF2, we will get rho g z2 minus z1 into dAz. And what is z2 minus z1 into dAz is equal to volume basically. So, rho g into dV, rho g into dV. So, it means that buoyancy force is equal to weight density multiplied by a small volume, right. So, for getting the net force on this body, we have to integrate. So, Fv, if we integrate this relationship, so left hand side we have a net buoyancy force in upward direction is equal to volume integral rho g dV, and this is equal to rho g v. So, buoyancy force can be calculated with the help of this formula, which is very common, means we all know this, that buoyancy force is equal to weight of the body weight of the liquid displaced by the body, rho g into V. What is V? V is the volume displaced of liquid, right? This we have to keep in mind. Now this is the buoyancy force. Next step is to find out at which point this buoyancy force act through. For that we have to use the concept of movement. So for that we have the cross hatched prism. What is the force? Force acting on this prism is equal to dFv is equal to rho g dV. Now what is the couple produced by this force about z axis? So for that we have integral of dFv multiplied by x distance. This distance is x, right, from z direction to the location of the prism. So x into dFb is the couple produced by the force acting on this prism about z axis. Now this is the buoyancy force multiplied by distance is equal to couple about z axis. If we want to know what is the net couple act about z axis by other prisms, so for that we have to integrate it. So we have integral sign here is equal to what is the net buoyancy force? Buoyancy force is assumed to be acting through point B in upward direction. This B is distance xv. So we have a xv distance multiplied by fb. This is the couple produced by a resultant force. So with the help of this formula we can calculate the xv, because we know fb and we know this integral, so we can find out xv. So xv is equal to, what is fb? Fb is equal to rho g v. So xv is equal to 1 over v x dfv. Dfv is equal to rho g dv. So rho g is cancelled. We can substitute the value here, and after doing little algebraic manipulation we can prove that xv is equal to 1 over v volume integral x dv. This is a first moment of volume. So which shows that xv will be the centroid. So this B is nothing but centroid of this volume. So we know that buoyancy force acts through the centroid of displaced volume, right. So we can calculate the buoyancy force, which is equal to the rho g v, where v is the volume displaced and this xv is the point of distance measured from z direction to centroid of displaced liquid.